So if I open this Excel sheet, can you guys see it?
Yeah.
Okay, cool. So you can see the whole display. So I can explain how all this stuff works. All right, Phoebe, whenever you're ready, I'll start.
Yeah, we can start now.
Okay, let's do it then. All right, so first thing when we're working with any data is we got to read in the data. So if you're new to RStudio, you would essentially just go to new file, R Markdown, and then, call it whatever you want. And then these gray chunks right here, this is where you actually write code. Everything else over here is just kind of like text, so you can like help keep track of what exactly you're doing. And then if you want to add, they're called code chunks. So if you want to add a new spot to write code, you do Control-Alt-I, and it'll generate a new code chunk for you. So you can do things like that. In this case, I kind of already have this one that I started, so I'm going to roll with that. Are there questions in chat? Okay, yeah. So if you don't have RStudio yet, or R, you need to download R first, and then you can download RStudio. The links are in the chat, and if you're having problems, feel free to reach out to Phoebe or I. So once we do that, we're going to read in the data. So before we read in the data, I like to see what the data actually looks like. So I'm going to go ahead and start with the Excel, since it's a little cleaner, but then I'll show you how to do the CSV. So this is what the Excel data looks like, as you can see. So every column is basically like a question that we ask them. So we ask them like what their name is, what their response ID was. Like if we go all the way over here, we asked them, they provide an example. Every row in our data is going to be an actual, we call them observations, but we're going to denote them as an actual person who responded to the survey. So row 2 of the data could be Billy Joe's response to the survey, et cetera, et cetera. So every row is going to be a person. Every column is going to be a question. So that's something to keep in mind when we're reading in the data. Now, R, for the most part, will do this for us. If you want to read it in straight from the Excel file, then what you need to do is you need to install this library called Read Excel. To do that, you're going to go to Tools up here, and you're going to go to Install Packages. And then it's going to ask you which package you want. You can just look up R Tools. Oops. And it would be there. You press Install. Oh, no, sorry, not R Tools. It's going to be called Read Excel. Then you just install it and you're good to go. Now, for some of these Excel packages, you do need to install Java first, and it can make things a little tricky. So if you're getting like these weird errors, that's probably why. So the alternative is to just read in the CSV. And if you don't know what a CSV is, it's called a comma separated values or something like that. So it's this junky looking mess right here. But basically all it does is it separates each column by a comma. So it's going to be the same thing as reading in the Excel. It's just going to look a little different. Each row is still a person, and each comma just denotes that we have a new question. So here's how you read in both. For the read.csv, all you got to do is look for the file name and the file path and just paste it in here as we call them strings. This is just a way to tell R these are words. So if you want like a quick way to find your files, so I could show you right here. Here I have a folder and I have this file right here. If I want to know where it is, I can just go to properties, and then right here we have the location. I can just copy paste this and then throw it in here. The only thing you're going to have to add is the file name and the extension. So in this case, I called it, what did I call it? It was racer.sln. So you could just copy paste this here. And then what you're also going to want to do is you're going to want to change all these backslashes to forward slashes, or I think I have that right. And this is just because of the way Windows handles file paths, but R likes it a certain way. So just go ahead and change them, and then it should work. And that's how you read in a file. You just throw it in here. And if you're working with the Excel, the only difference is you need to specify which sheet you're reading in. So because we have 3 years, if we go back to the Excel sheet, we're looking at the first sheet, which is 2018. But if we want to look at the data for 2019, we go to the second sheet. Now this function just assumes if you don't put anything in, if you don't tell it which sheet to go to, it's just going to take the first one. So you just do this sheet, we call it an argument or a parameter. You put in the sheet equals, and then the name of the sheet you want. So in this case, we want 2019. So we just tell it that we want 2019 and it'll go ahead and read it in for us. And then if we want to go ahead and look at what the data looks like, we can print 2018, and it'll take a little bit to print because it's a little long, but we can look at what it tells us. So we have 245 columns, so 245 different possible questions, I suppose, we could have asked. The way the data is set up, it's a little trickier. And then we have 921 rows, so 921 total people who responded to this survey. And then we can look at 2020 as an example. And same deal. So we have 125 columns. So there are certain questions that were left out here, so we're not going to have to worry about those. And then we have 312 people. So overall, less people responded in 2020. So that should be something we keep in mind. All right, so that's reading in the data. Does anyone have any questions about that? And if you want me to go ahead and paste this in the Zoom chat right now, I can. If you want to just follow along, I'll send the R code out later, but let me know. Otherwise, I will move on. So let's talk about what some of the data actually looks like. So I'm going to go to 2018 real quick, and we're going to go here. So this question, I believe, asks something like, do you suffer from any of these or something like that? Or are you concerned about something like this? And the way it's set up is each column is a possible thing they could have been concerned about. Lauren, if you want to correct me, please do. So for example, we put anxiety, arthritis, asthma. So these are maybe like things people can suffer from. Something in chat. Okay, cool. And so they're not exactly limited to one response. So they can pick any of these. So essentially we gave them like a list, and it's like a checkbox. They could checkbox all the ones that apply. In this case, because we're keeping track of whether they checked it or not, if it's a 1, it means they did check it. If it's this null, that means they didn't check it, so there was no response. So for example, we have Zeng. Oh, I'm going to butcher that name. Zeng has, they put 1 for anxiety, but they put nothing for arthritis. So they might have anxiety, they might have cancer, but they don't have any of the other things. So what we're really interested in here is we want to go through and see how many people responded yes to each of these. So essentially what we're going to want to do is we're going to want to go, let's say we're interested in arthritis. We're going to want to go down the arthritis column, and we're going to want to count all the ones. If there is a 1, then it means someone responded yes. If we get this null, then they didn't. So we're just going to throw it away. So which one, the question was, which of the following health concerns would you like to know more about? So how are we going to handle this in code? Lucky for you, I wrote this little function that kind of does it for you, but I'll walk you through what it does. So essentially what it's going to do is it's going to take all of the, let me see if I can find it real quick in here. It's going to take all the values in the column. If it's null, it's just going to kind of throw it away. And then if it's a 1, it'll keep track of it. We're going to go ahead and add all the 1s. And then we're going to divide it by the total amount of responses per the column. So basically what this is giving you is the amount of people who said yes over the total amount of people who responded. And this will give us a proportion. So when you get this function, all you got to do is you just highlight it. And then if you press Control R, you can run it. You can also just press this little green arrow. And when you highlight the function, it just kind of tells R, okay, this is a function that I want to know. If you've never heard of functions before, if you're new to coding, a function basically works the same way it did in your high school math class. You put something in. In this case, we're putting in a column, and then you get something out. In this case, it gives us the proportion of people who said yes. And that's all you really need to know about how this works. So for example, here I want to get the total amount of people who said that, let's do arthritis. So this will be the total amount of people who said they were concerned about arthritis and they want to know more about it. So we have our, what's called a data frame, and that's what this big old rectangle right here is with all of our data. If we want to access a specific column, then we put this $sign right here. And then we are going to put the name of the column in which we want. So in this case, we want arthritis, and RStudio will help filter them for you. So I'm going to go ahead and pass this in, and just so I can show you kind of what exactly I'm passing in. If I run this, it's going to go ahead and print out just this whole arthritis column, and we'll see however many of them are there. In this case, it's like 900 or something like that. So let's go ahead and pass this in. And when we get that, we get this percentage right here. You don't really got to worry about this message right here. And basically what this tells us is that of all the people who responded, about 29-ish% of them said that they were concerned about arthritis and they wanted to know more about it. That was the question. Yeah, so which of the following health concerns would you like to know more about? So yeah, that's essentially how we're going to want to handle these kind of questions. We're going to want to get the proportions, and then using those proportions, we can perform some statistics on them. Last meeting, I think Lauren mentioned the chi-squared test, so we can use that. We can even do like specific proportion tests. So if we wanted to test like are people more concerned about arthritis versus cancer, there's ways to do that. I won't go too into it here. And thankfully R will usually just kind of do those for you. You just do kind of what I did here, pass in the data and it'll give you the result back. But for now, what we're interested in right here is this proportion. And then we can eventually graph these proportions, and you'll be able to just quickly see, okay, this is how many people cared about arthritis. This is how many people cared about whatever it is. So for those of you who have a question that looks like this, this is essentially how you're going to want to address it. Any questions?
Can you post the function in the chat so that anyone who wants to like follow along right now?
Yes.
Template.
All right, so there it is. Go ahead and just copy paste that into your RStudio, and you should be able to use it. I call it count responses. So this right here, this is the name of the function. And it's just going to count how many people said yes. Cool. Any other questions? If not, I will take your silence as we're good. All right. So the next kind of question I want to talk about is these questions. Where is it? So we have questions like this where it asks, it would probably be easier if I just go Excel. Where we are, we're essentially given like a statement. So this statement says leaders at UCR are actively engaged in promoting stuff. And then we're given a number from 1 through 5. So if you ever taken like those personality tests and it's like least likely or least agree to most agree, this is essentially what the question is. 5 being I agree with the statement the most, 1 being I agree with the statement the least. So how we want to answer these questions is we just want to take what they gave us and convert it into words, because we are humans and we like words. Numbers are a little harder to work with. And eventually we want to take those words and turn it to a picture, because a picture is easy. You can just look at a picture and understand what's going on in 5 seconds. So how do we do that? Once again, I have another function that kind of does it for you. If you're interested in how I did it, basically what I'm doing is I'm checking if, so we're making another, we call them vectors, but essentially another column. And we're just checking the current column and saying, okay, if it's a 1, put strongly agree. Well, I think this needs to be changed because this is for the COVID survey last year. So I'll change it right now. But basically, we're going to change it to, so if it's a 1, we'll put strongly disagree. If it's a 2, we'll put slightly disagree, or we'll just put disagree. If it's a 3, we'll put neutral. If it's 4, we'll put agree. Oops. And then if it's a 5, we'll put strongly agree. So, or anything else, we'll get an error, but we shouldn't get an error. So that way, if for some reason someone put something they shouldn't have, like they put like 27, it'll just throw that away. And then we'll run this function. And then when we run it, so let's say I want to know about the question, UCR cares about my health and personal well-being. I run this, and then it turns all of our ones and stuff into words that we can better work with. And if I look, I see some errors. So looks like we have some people who put things they shouldn't have. So what we can do is we can throw away those errors. I can show you how to do that. Could do that with something called tidyverse, which we're going to need to create the bar plot anyways. So let's go ahead and do that. So if I load up tidyverse, which is another library. So like I said, if you want to know how to install a library, go to install packages, and then you can just look for it. It's called tidyverse. Tidyverse is basically just a compilation of a bunch of really useful stuff. So I would recommend, if you want to get started somewhere, get started here. And then we're just going to go ahead and load the library. So when you load the library, it pretty much just it's kind of like throwing all the cards on the table, except it throws all the functions and variables on the table that come with this package. But if you're not careful with it, if you load up a bunch of different libraries, they can all get mixed up, and sometimes R won't know which one you're talking about, especially if they have similar names. So if this library has a sort function, but then this other library has another function named sort, things can get a little messy, and those can be some kind of tricky errors to catch. So if you ever want to make sure you're using the right function, you can do this. You put the name of the library, and then you put these 2 colons, and then it'll go through and tell you all the functions that exist within that library itself. So that's a good way of good practice of just keeping track of what exactly you're doing and making sure that you're using the right functions that you need to. In this case, we're going to be more interested in this dplyr. See if I can spell that right. So like I said, tidyverse is just a bunch of different functions. We're going to be interested in this one. And this is a library that lets you filter data, basically. And we can just kind of go through and get rid of the errors this way. So we'll use a filter. It's called filter. And then we'll pass in this case, I call it response. And then the second argument will be what exactly we want to filter out. So I believe it's been a little bit, but I believe the way it works is you tell it what you want to keep. So in this case, we want to say response. So the current observation. I got a question in chat. Oh, cool. Thank you. Does not equal, and then we're going to say error. So basically what this is saying is that if we get an error, throw it away. And let's see if this works. Spelled it wrong. Oh, I see. So the way it worked, this applied to a factor method. So we can try something else. It's kind of coding. You just got to try, see what works, see what doesn't. So we'll try response, and then we can try response does not equal factor. Let's try this. No error. All right, there we go. So we're going to use something else called the subset. This is built in with R. And what this does is should get rid of all of the errors. And just if you want to see how many you have, so before we had like 921 or something like that. Now if I print, so if you want to see the link, I'm going to go ahead and save this. And to save, we use this assignment operator, this little arrow looking thing. It's going to override what we had here and put it here. And if I want to know how big it is, I can just put in the length function. And this will tell us how many rows we have in this vector. So we have 877. So around 50 or so of those things were errors. And errors are no good to us. They don't tell us anything. So we'll just throw them away. Last thing we're going to do for now is we're going to create a bar chart. So why would you want to create a bar chart? Well, bar charts are nice because they're a quick way of telling us proportions. So, if you see one bar chart that's twice as big as the other, then we know that there are about 2 times as many responses on one versus the other. So it's a nice way of getting proportions and counts. We call it discrete data, but this is for data that is like countable essentially. So if you were like measuring temperature or money, you wouldn't want to use a bar chart because that's what we call continuous data. In other words, you could slap a decimal on it and it'll still make sense. In this case, we limited it to 1, 2, 3, 4, 5. So you can't respond 3.5. It has to be one or the other. So we'll use bar charts. To do this, I'm going to go ahead and use ggplot2. This is the fancy dancy way of making your bar charts, and this is how I think they're going to want us to do it. So this will be a nice template for everyone to use. This is the code for it. I'm going to go ahead and walk you through. So the first thing you're going to want to do is you're going to want to use the ggplot2 library. You can either do what I did here and explicitly tell R, hey, you got to get the ggplot function from ggplot2, or you can just load up the library and it's called ggplot2, whatever you prefer, or you could use both. I think it's good practice to let R know. You won't run into as many errors, but whatever you want to do. So then the first thing we're going to do is we're going to specify what the data we're actually using is. So we're going to use this data argument and we're going to set it equal to our response, which I have right here. And because this likes to read in data frames, in other words, it likes to read in this. It doesn't really like to read in just a bunch of words, which is what our vector is. So I'll print it out just to show you. If I print out the response, we just get this big old list essentially of responses. But this function doesn't like that. It likes nice organized data like this. So what we'll do is we'll kind of use a little workaround. We're going to turn our list into a data frame. And you can do that using this function as.dataframe. And when I put in response, we essentially get the same thing. We get our list. It's just, it looks nicer for R, and R likes this a lot better. So that's a little workaround we'll do. And then we'll go ahead and set these, what we call aesthetics. What that means essentially is just like you're setting your specific, what you want specific parts of the bar chart to be. So in this case, we have an X and a Y. For our Y, we want it to be the actual count. So it's going to go through and count, okay, how many people agreed, how many people disagreed. And it'll do that a little later with us telling it to, so we're not going to worry about that. But for the X, we're going to want to put the response. So I'm just going to run this real quick so you can see what the bar chart actually looks like. So we look at what it looks like and we look at the X axis right here. You can see that I put each of the 5 options in the X axis. So that's why we're setting our X axis to the response variable. It'll go through, it'll make 5 separate columns essentially, and then we can count how many. Then we have this fill argument right here. What this is going to do is it's just going to tell R how it wants you to color the objects. So like I said, we're humans. We like easy pictures, understand it like that. And a great way to do that is to color each of the bars so that we immediately know they're different from each other. And I think what we're going to want to do is specify it a little later to go with specific colors. So like a UCR color theme or something like that. But for now, I'm just going to use the defaults. And what this will do is it'll color each of the different responses something different. So in this case, I pass in response to fill and it'll say, okay, strongly agree, we'll give it this red color, agree, we'll give it this olive color, et cetera, et cetera. So it's just going to go through and assign a color to each of our different options there. Once we do that, I have this extra thing. I'll tell you what's at the time. So, okay, after you do that, you're going to put this plus, and then this essentially tells it, okay, keep going. So now we're going to want to tell ggplot that we want to make a bar chart. And to do that, we're going to just type in this geom bar argument. Now, the way ggplot works, it's a little complicated, but usually the way it works is you put in what you want your X and Y to be, and then you put in what kind of actual chart you want. So you could put in like a geom histogram, geom box plot, geom scatter plot, whatever you want. In this case, we want a bar chart, so we'll put in geom bar. And then we're going to put in a plus, and we're going to add something else, and this is going to be geom text. This is going to be the actual text and labels you see on the bar chart. And this stuff's really important because it gives our bar chart meaning. We don't just want to present these random bar charts because then no one's really going to be able to understand them. And even if we're there to present them, if someone else, for example, has to use our data, and they don't know what it means, well, then we're in trouble. So we want to make sure to be very explicit and say what everything is. So here I'm going to go ahead and this is a little formula I use to label these proportions right here. And we like these proportions because they can summarize the counts very quickly. So if I just told you that 100 people said strongly agree, it doesn't really tell you a whole lot because you don't know how many people said otherwise. The proportion basically does that for us. It tells us, okay, well, 100 people strongly agree, but that's only 11%. So really only around 11% of people strongly agree with this. So we want to make sure to include these. And then we can put the counts on the y-axis just to give a more exact number of how many people responded. But this will tell us relatively how many people responded. So we can compare each observation with the other. And this is just a fancy little formula that I made to go ahead and write these counts. You don't got to worry too much about that. Next, I put the stat equals count argument. So earlier I had said that we want our y-axis to be the amount of counts we get per response. And this is where we actually tell the bar plot, we tell R, okay, set the y-axis to counts. So you're going to want to make sure to include that there. What this is going to do is basically just move the text right here up and down. So your bar charts are probably going to look different from mine depending on the data. So if you want to align the proportions better, like here, we probably want to align them better because we don't want them to overlap. So I'll probably want to change this to a higher, lower value. You can play around with that. Size is literally the size of the text. So if it looks too small, if it looks too big, you can adjust that right here. Last thing we're going to add is this GG title. And then this is literally just the title of the plot. So it says UCR cares about my mental health and well-being. That's the question we asked. So we want to make sure it's on the bar chart. And then I also have this. It's called theme.legend.position and it's equal to none. So I'm just going to get rid of this real quick just to show you what it will look like without this. So if I put a hashtag, it comments it out. And what that means is that this isn't read as code. It's just read as nothing. And you can just make little notes for yourself. So normally if we'd run this, we'd see this we call it a legend, but it's kind of like a extra information of like what everything is. But for us in these bar charts, it's a little redundant because we can clearly see what everything is looking down and it just kind of takes up space. So we're just going to ignore it. We'll tell R to not display it and it'll give us nicer looking bar charts that we can work with. And that's how you can address some of those questions. So for those of you who have questions where you need to address how many people like disagreed or agreed with these questions, this is a nice way you can do it. If you want to take this even a step further, so really the only thing you're changing is the response right here, which is you would just change this to the appropriate question you have. If you want a little challenge for yourself, what you can do is you can try to automate this essentially. So all you have to do is pass in the actual question you want and it'll go through and take care of everything for you. If that's a little challenge you want to do, go for it. If you want to work with me to do it, I can do that. I'd be happy to. It'll save you a lot of copy pasting. If you want to just copy paste, that'll work too. So that's everything I had for now. Do I have any other questions? I know I moved a little fast, so feel free to ask.
Yeah, is there anything that you guys would want repeated, or maybe we can like paste the code in the chat again?
Okay.
Alan says, are you talking about making a function that'll make ggplot? Yeah, to make multiple plots.
Not only will it make ggplot, it'll do everything else for you here. If you want to work with me on that, we could do that. And essentially what it'll do is it'll make your life, basically you'll be able to get this bar plot in one line of code.
Yeah, I said this in the chat, but I'll just say it. Christian's very good at like creating these functions and like automating these processes. And so if you want to challenge yourself to try to do the same thing, it's a really helpful skill to have, especially when you have like such like big data. Like this data isn't like that big, you know, but when you work on other stuff in the future, the naive approach isn't always the most efficient way.
That being said,
So, yeah.
You don't always have time to do that. It is faster to just do this. If you just want to, okay, I have a different question. Well, I'll just put in a different question, df, what do I call it, 18. And then you can do can look for it, something like that. You'd have to repeat all this stuff too. But sometimes you can just want to copy and paste and change what you need to change. It really
Yeah,
depends how much
sometimes
time you
that's
have.
easier than trying to figure out how to do it, like, to create a function. So just whatever like works for you and what's faster.
Yeah. So do whatever makes sense to you. There's no right or wrong way to do it. As if it gets done, it gets done. Any other questions?
I have a couple comments. Can you hear me?
Yep.
Yeah.
Okay, for our data, I believe Metrics said that if someone answered the survey twice or multiple times to use the most recent, could you go over quickly like how to filter out multiple responses?
Okay, sure.
And
So
then, sorry, and then my other question was for the ggplot. Since we have 3 years, I think we're going to split it by year so they're all on the same chart.
okay,
Right.
so yeah, we're gonna need to do something that's called they call it a dodge. I don't know why they call it
Yeah,
that. But
position.
essentially what we're gonna look for is we're gonna have like one column is gonna have 3 bars. There's ways to do that, but I will probably need a little bit of time to get to that. I don't know if I could just bust that out. But
Yeah, no
let's
worries.
go back to your other question. So you asked how we can filter out repeats, basically.
Yeah, there's a couple like 10 or something.
Okay, so this is what we can do. Here's one way. It's gonna be done in real time, so forgive me if it doesn't work, but there is a function in R that's called isUnique. It's called isUnique. And it's gonna take in a vector or a column basically and return to you a new one just with all the ones that are unique. So in this case, we would need a way to make sure they're unique. So I think I saw there was like a response ID, if I'm not mistaken.
I think for me, when I filtered it, I used the email, but maybe
Okay, let's do
ID,
that
I'm
then.
not sure.
Because the email, the ID might be different if they respond at different times or something like that.
Yeah.
So we'll use their email address. So for 2018 data, if I do df18, what is it? Recipient email. And I run this. So what does this do? Got a bunch of nothing, so that's not good. I think this might be not the column then. Let me try. Was it please enter your?
Yeah, I think I tried that. You need a period in between every space.
Let's see. Let me look at the data again, because I noticed some of the columns are empty. So it was called. Yeah, so we look at the email. For some reason, this didn't get filled out, but there was another column that had it. Where is it? Oh, right here. Okay, so it's this QID41 text. So if I'm just gonna go ahead and copy paste it here. And if we paste that, this will go through and tell us which ones are repeats and which ones are not. So we know which ones are repeats and we know which ones aren't. So now essentially what we could do is we would need a way to get the most recent ones. How do we do that? Probably would, it might be easier to do because we don't have too many repeats, is maybe work a little backwards. So let me first show you how you can only get the ones that are unique, so no repeats. So if I do this, I'm going to put brackets around the isUnique. So remember that this is returning a list of true or false. If it's true, then it means it's not repeated. If it's false, it means that it is repeated. If I put these brackets around our vector, which is right here, it's going to go through and it's going to look at whether each one is true or false. So if it's true, okay, we keep this. If it's false, then it just kind of gets rid of it. So if I run this, then we get a list of emails and we're only keeping the ones that are not repeats, so only the ones that are unique and used once. So we have around 910, it looks like, that are unique. And let me show you how you can get the ones that aren't unique. So if we look at the ones that aren't unique, all we got to do is add this exclamation mark. For those of you who've taken computer science classes before, you might recognize this. If not, all it means is just take the opposite. So it's going to reverse our trues into falses and our falses into trues. So in this case, this tells us keep the ones that are unique. And then this will let us know only keep the ones that are repeats. So let's go ahead and try that. So now we can see where the repeats are. We got 2 right here. We got 2 right here, et cetera, et cetera. And then what we could do from here is we could find I guess the actual indexes we want and just kind of append them, I suppose. So in this case, you said you wanted to keep the second one. So we'd find all the data for this one right here and just kind of throw it on to this. We could just put it at the end. That would be, I suppose, a less elegant way of doing it. But as far as I know, the isUnique function will only keep, it'll either only keep none of the repeats or it only keeps the first one. And if what they want is the second one, and I'm going to assume the second one is the most up to date, then this is just like a simple way we could do it. If hopefully there aren't too many repeats, then we can just go through. So if I want to know, so what I would do now is I could go and extend this a little further by applying it to the data frame itself. So if I look at the data frame, our data frame bracket is composed of 2 things. So here we have our rows. Here we have our columns. So we're going to want all the columns. We're going to leave this blank. And in this case, what we want to do is we want to tell it, keep the rows that we specify. So in this case, let's take a look at the ones that aren't unique. And essentially what we did here is the same thing we did here. We're just telling it, look at these specific rows, but let's look at the columns as well. So if I print that, it'll give me so it looks like we have 12 that aren't unique. And we can just kind of filter them out from here. So I'm guessing since we have every other one, we can come up with like some even odd scheme to keep them. So we could just say if the index is odd, then throw it away. Otherwise, keep it. We'll put that into some new data and then we will append it. So I guess we can try and figure that out. Does R have like an isOdd function? If anyone wants to help me Google that real quick. If not, we're going to do some live debugging.
I just said make sure there aren't any triple responses.
That's a good point.
Yeah, you don't know if they're like, alternate.
So it looks like in this case, there's no triple responses, but it is something we should be careful about. So thank you for bringing that up. So yeah, so it looks like we can just take like a even odd. I'll show you a very computer sciencey way of doing it then. We can just do the mod operator and we'll mod it by 2. And this is just a fancy way of saying, check if it's even or odd. In this case, we only want the even one. So if mod 2 is equal to 0, if you've never seen the mod operator before, basically what it does. So here, let me pull up Paint real quick. Can you all see Paint? All right, so let's take some simple division. Oh God, 9 divided by 4. So what does this really mean? So you guys know that this will give you what, 2 point something, but what this essentially means is you take 9, subtract 4, you have 5, subtract 4 again, now you have 1. Now we can't subtract 4 anymore because then we'll go into the negatives. So essentially what the answer to this is 2 remainder 1. So we can put 4 into 9 and 2 times, and then we'll have 1 left over. The mod is going to give you this remainder right here. Now let's talk about how we can use this to tell if it's even or odd. So a special property about the mod. So let's say I do mod 2. Oops. Sorry, I suck with paint. If I do mod 2, a special property about mod is that we'll only ever get, so if I do mod n, we'll only ever get n minus 1 ... to 0. So we're never going to get anything n or bigger. We're always going to get something n minus 1 or smaller. So in this case, for n mod 2, it's going to return either 1 or 0. Now, if we know that an even number divided by 2 will go in perfectly, we won't have any problems with any remainder. So if we get 0, then we should know it's even. And if we get 1, that means that it's not even. And that's kind of how we can use this to check. So let's go ahead and try that. What it does not like. Doesn't like this. Let me see if I can fix that. So I think that doesn't like something about the notation. So we'll use the subset function. We can do this. Got my caps lock on. So we'll take the, or if not, what we can also do is we can generate a range of numbers. So we'll say, was a sequence index. Oops. And we'll set a sequence from 1 to the length of our thing. So in this case, it'd be the length of this. And what this will go through and do is it'll just give us a list of numbers. So in this case, it's going to be, because we had 12 responses. Ooh, that's not right. Sorry, it should be the length of this data frame. Not
If you
this.
can't get it like working right now, don't worry like too much about it.
Yeah,
But it's kind of like the same. Yeah, it's like the idea of just how to like filter out like the repeated responses.
So
and if you guys aren't able to do it, you can always do it like in the data as well, because I have like the original data set and we're not gonna like turn that in or anything. So if, as long as you know that you need the most recent participant, if you know which ones are the repeats, you can just delete the ones that are repeats that are the first response. That's totally fine.
okay, yeah, if you want to do
Yeah.
that.
Yeah, you
Lynn
can do it manually
says
as well.
summarize count is equal to n plus filter. Not quite sure how that would work. Alan says there's multiple ways to do this. Yeah, this isn't the only way, but you could do something like this. Essentially, I just need to get all the indexes and get the even ones. So I'm just going to pretend it worked and I'll show you what it would look like. So in this case, I'm just going to get all the even numbers from, we're going to go from 2 to 4 to 6 to 8 to 10 to 12. And then if I put this in, call this index, it should just return the ones we want. So there we go. You'd get your 6 unique ones. And if you want to come up with some scheme to get it, go ahead. That's how I would approach this. Any questions about that? I'll try and finish this and then here, I think you just gotta add this. And I can get it out there so I can save you the trouble. Not like that. But yeah. Any questions, feel free to let me know. So I think if I run this, just get 1 and 2 because of some reason. Anyways, that's a way you could do it. If you want to go through and just figure it out. If not, I'll work on it and we can even work on it together if you want. Any questions?
I apologize, Christian. One last thing.
Go for it.
going back to the ggplot and using the dodge function with all 3 years, can you go over quickly just the rbind and I think we were suggesting that they copy paste their columns and make their own data sets for their questions and then use the rbind function since we weren't able to clean out like how every year is different and has different columns.
Okay, so this is
You
how
know
I
what I'm
would,
referring to?
yeah, so this is how I would approach it. So let's say we're interested in, we'll do arthritis or not arthritis. We'll do this one again. So let me make a new one. Start down here. So here I was interested in whether or not UCR cares about my personal well-being. So we'll call this response 18. And this will be the response for 2018. There it is. But this doesn't, there's no way of knowing which year it is. So a nice little thing we can do is we can make a vector that will eventually tell us what year it is. And because we know all of these are 2018, we can just tell it that it's 2018. So here's a little trick you can do. So I'm just going to make this vector year, and I'm going to equal it to response 18. So it's just going to copy it. And then I'm going to override all of those words with just 2018. I think that might work. Or I will just 2018. No, so we got to go through and actually make each element 2018. I'm sure there's a fancy way to do it, but I'm just going to use a for loop because I am lazy. So we'll just say for, man, how to do for loops in R. Does anyone remember how to do for loop in R? I never do. I think it's for, so we'll just equal I to 1. For I in sequence 1 to say the length response. So however many, however big this vector is. Then we will set the current index of the year to 2018. Let's try that. Did not like something there. What did I not like? Oh, we need parentheses. I think I need some too. Something in the chat, if someone can read that to me. Let's try that. So now if I print year, so there we go. Now we just have a big old list. This is 2018. So now what we can do is we can cbind response 18 and the year. And this will essentially just glue the two columns together. So we'll have a data frame. So I'm going to run this. And what this does is it gives us the response. In this case, I want it to be the actual word. So I will do this. I'm going to run this in here. Don't know why I didn't save. Oops, didn't like that. Anyways, you can play around with it, but what it should do essentially is it'll make the two columns kind of look like how we have them up here. So if I print our data frame, we can see that essentially our columns are kind of like stuck together in one thing. And it'll essentially do the same thing here. For some reason, I'm getting this error with the response. I'm sure it has a fix that the workaround we can figure out. But you'd want to do something like this, and then you'll want to go through and do the same thing for each year. So I could just do it for 2019 real quick, I suppose. So you're gonna want to do something. I could automate this later, but you'll want to do the same thing for let's say I in length. What did I call it? DF 2019. DF19. And then the same question. So UCR cares about my personal health and well-being. And then we'll set year equal to the same thing essentially, and set each index to what we need it to be. And once I do this, it's not what I wanted. Once I do this, I'm gonna do what's called an R-bind, and that's essentially gonna stack the two data frames together. So if one had 50 rows and the other had 100, your new one would have 150 rows. And that's just kind of a way you could, oh, I just realized this should be parentheses. Where the issue's coming from. And we can do something like that. So for this, I'll just change this to 2019. This will give me a way for so when I eventually put it into ggplot, it'll give a way to eventually tell R, okay, you need to separate 2018 years from the 2019 years. And then we can have our nice staggered charts. And let me just look it up and show it so everyone can kind of see what exactly Lauren means if you're not sure. Let me look
Yeah, sorry, Christian, for putting you on the spot right now.
my coding to the test. So essentially what we want is something like this. We want like these staggered bar charts, and then like, so this one could be 2018, this one could be 2019. In our case, we're gonna have 3, so it would be like a 2020. And then each of the x-axis will still be, so this would be like agree, disagree. That's essentially what we want. And it'll give us a very nice compact way of displaying a lot of data in very little image. Does that make sense?
So you want the bar charts to be both stacked and dodged, like in the example that you pulled up?
I think they should just be dodged in the dodge position.
So then are we also specifying like between like faculty and like students? Or just
I think those ones she wanted in like separate charts. In the example that she gave for question 1, you can see there's like it's separated, so like students have their own, faculty have their own, staff have their own, but then they're separated by year.
okay. Yeah, that leads me to like another question about the data. How do we like distinguish like each observations from one? Because I don't think there's like a column that specifies like who's who.
Yeah, I was just about to ask that too.
Yeah.
Faculty, student, and staff.
Yeah, faculty, staff, students. Like
I think there was a question. You go to the data set.
I'm looking for it right here.
I think it was near the end.
Okay. I don't see anything, Lauren.
Okay, sorry, I'm looking for it right now. It's possible that it could be missing from some of the data sets. I know for sure it's in a couple of them, or at least one of them, but it could be missing from some of them. And if that's the case, then we might have to just like not include that.
Okay. Yeah, I don't see it anywhere. So maybe you can go to metrics.
2020, in the 2020, there's a what is your UCR affiliation question. So that's a student, other, staff, or faculty.
So it's only in 2020?
Yeah, and then in 2019, there's a what is your UCR affiliation? That's column DK. They're both near the end. I think 2020 might not have it. And I think that one was outputted differently. That's why the column names are all like kind of weird. They're like random numbers and letters, it looks like. Yeah.
What
For the
about
That one
semester
might not
courses.
include it.
Yeah, I don't see any in 2018. So unless so maybe you can let metrics know.
All right. I mean, if that is the case, yeah.
It's not much we can do.
Hmm.
So if that's one of your concerns right now, you can go ahead and hold off, or you just want to focus on the 2019, 2020 data part of that question, you can do that too. And just say, you know, when presentation comes, you could just say, hey, you know, we didn't have this information for 2018. So general rule of thumb, I feel like when it comes to stats is if you don't have information, just don't, or like you don't have all the information, just don't include it. So for 2018, you could, if that's the question you're interested in, is like the difference between faculty and staff, you could just leave 2018 out and focus on 2019, 2020. And just, you know, make sure to mention that that's all the data includes. Okay.
Yeah, and maybe if that's a concern as well, maybe you could put 2018 in like its own graph or something like that. I'll double check with metrics about that.
Okay.
And then really quick, also, I just realized too, since 2018 is a different data set, or it was outputted differently, if you wanted to use like the column combine and rbind functions, it might affect it that the name is different. So you might have to change that so that they're all the same for your questions.
Yeah. So if the question, I believe it shouldn't affect
For
it. Like
rbind, right?
for rbind, what matters is that the columns are the same. So if you try to just combine all the columns at once, you're gonna get problems, which is what I don't recommend you do. What I recommend you do is you take the vectors that you need, and then you can combine those. And that's pretty simple to do. So instead of essentially what I'm trying to say is instead of trying to combine the entire data set right here, just try to combine the columns you need. So if you're interested in like the response ID, just go ahead and combine that with the response ID from 2018, 2019. Don't try to do it all at once. It's all going to fall apart and things are going to get messy. And if you run into problems, it's going to be harder to find out what the problem actually is. Try to, especially because we're all assigned to different questions, try to just focus on your part and your part alone. So if you can find like what exact questions you're answering, go ahead and just extract that data out and just focus on that. You can throw the rest of it away. Because for most of us, I think a lot of this information is not super relevant. So, you know, just throw it away. Don't worry about it. Focus on what you need to focus on.
We're over time right now, so
Okay, yeah. If you need to go, feel free to go.
yeah, just before like everyone goes, just you know, just remember that like we're here to like help you guys out if you like need it. So please don't hesitate to like message us through Discord, and you know, we want to have like that clear communication so that you know this whole project is kind of you know put together, and it seems like you know a collective piece.
Yeah, you know, just if you need any help, reach out. I will be more than happy to help you. I will struggle through the code with you. Especially for those of you who haven't really done this kind of thing before, I'll be happy to walk you through it and explain what's going on. So yeah, if you're leaving, when should we have this done by? Lauren, do you want to answer that? And Alan, I'm sorry about question one. I'm not gonna lie, I looked at question one and I was like, thank God I'm not I'm not answering question one.
Yeah,
But
question one had changes throughout the year, so I know a lot of it's different. As far as the due date, I believe Metrics gave us February 10th. I think that we should try to get it done maybe a couple days prior to that, just so that we can go through as a group and make sure everything looks good and we know what we're presenting. But I believe the date was February 10th. Vishal, is that right?
Yeah, that's right.
so I'll probably try to host more of these little work together sessions, and I can iron out the code a little more than I did. And you guys can come, and if you need help, you can get it here. If not, like I said, just reach out to me. I'll be more than happy to work with you.
Alan, for question one, yeah, I think just try and find like the ones that are uniform throughout question one and like the responses that remain the same. And then from there, just take those responses and then you can divide those ones up among your group. But the rest of them, just don't worry about it because
Yeah.
they have changed.
Yeah, I was just thinking of looking at ones that seem relevant and are uniform between the three, and then just throwing everything else out.
Yeah, I'm sorry about that one. I know that was an interesting one.
I thought it'd be fine. And then I got the curveball that there were faculties and students in other data sets too, because the example using 2017 and 2018 didn't even have those.
Yeah.
So now I have to figure out that too. It should be fine, hopefully.
I think actually there may be still some problems with question one. I'm not entirely sure because after I told Metrics about the issue, I was kind of like going through and I realized that when I separated all of the data from it used to all be in one column, I was using a template that or a survey that they had given me, and some of those could have been different as well. But I think you should just use whatever columns that we have because clearly those are what Metrics focused on most.
Okay. Metrics, please. Metrics, why?
I'm gonna stop the recording.